Okay, so we're going to finish out the notes for this year on section 5.6. We're going to look at something called the hinge theorem and the hinge converse. So I'm going to put my hands down here and show you the way a hinge works. So I want you to take your hands and put them together at your wrists right now. And I want you to open the hinge really wide. So do you guys see that the side across from your hands, or your fingers, is open really wide? And then if I close the angle further, then the side gets shorter and shorter, and then it gets wider and wider, and longer and shorter and shorter. So this is the way a hinge works. So we're going to put that concept into two theorems, a theorem and its converse. So you guys remember SAS congruence shortcut. So we're going to be using SAS because that's how the hinge theorem is built. So I want you to go ahead and tick the 7s, and then I want you to double tick the reflexive side. That should seem familiar to you. If you have SAS, then you're allowed to compare two things. So notice that these angles are included. So go ahead and put little marks on them. Even though they're not identical to each other, they're included. Okay, the angle that is bigger is 53. So we're going to circle 53, and we're going to go across from 53 and see a 10. That side has to be bigger than the side across from the 49, because since 53 is bigger than 49, the side across from the 53 will be bigger than the side across from the 49. So that means that x will be less than 10. Now, this is kind of what we did on the other page of notes, but we're using two triangles this time to compare instead of one triangle. So in the last notes it was in one triangle, now it's in two triangles. All right, here is an example of the converse. This time, I'm going to double tick the reflexive. I'm going to make sure that I have side, angle, side, because I'm dealing with two triangles. So notice I have two sides, and now I'm going to circle the included angles. All right, I'm going to be able to compare these angles based on the sides that are opposite them. So 15 is larger than 10, so the angle opposite the 15 will be larger than the angle opposite 10. So x will have to be greater than z. And again, I'm doing it in two triangles, which is why I have to use SAS. So some books call this SAS inequality. Our book calls it the hinge theorem. Okay, so let's fill this in. If two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side will be longer. And if that isn't the worst theorem you've ever read, I don't know what is. That is really long and very complicated, but all it is saying the longer the side, the bigger angle across, and the bigger the angle across, the longer the side across. Okay? So we'll go ahead and fill in the converse, which was this one. This was the opposite of this. This says if two sides are congruent to two sides, and the third side in the first triangle is longer than the third side in the second triangle, then the included angle is bigger or greater than the included angle of the second triangle. Okay, so this is the theorem. That picture went with the theorem, and this is the converse right there. So let me show you how this works. I'm just going to do like a few examples with you, and then you're going to finish this and check it after we shut the video off. Okay, so let's go to number 1. Let's look for SAS. You have to have SAS first. So we have a pair of sides already marked, and then you got to find another set of sides. So let's go ahead and double tick the reflexive. Okay, circle the included angles. The included angles we're going to be comparing based on these sides opposite. So 10 is bigger than 7, so the measure of angle 1 will be greater than the measure of angle 2. And I'm just going to put a greater in between them to show that 1 will be bigger than 2. Okay, let's go to number 2. Find two sets of congruent sides. So tick the 5 and the 5, and then double tick the reflexive. Now you have two sides. Now go circle the included angles, because it has to be SAS. Now go across from the included angles. 8 is bigger than 7. Since 8 is bigger than 7, angle 1 will have to be greater than angle 2. So just put a greater than between those angles. Now what we're going to do is use the other one. So these were both using the hinge converse. This is going to be using the hinge theorem, which is still kind of works the same way. It's just backwards. We're going to look for two sets of equal sides. So tick, tick. We're going to double tick the reflexive. And then we're going to circle the included angles. Now this time we're going to take the angles and use them to compare the opposite sides. So since 26 is bigger than 24, BZ is bigger than BX. Okay, so I'm going to put in a less than sign between these because BX will be smaller than BZ. Now I'm going to skip these three, and you guys are going to go back and do them and check them with the answer key after the video. And I'm also going to skip these three, and you're going to do the same thing. So after the video, you'll go back and try those three and then check with the answer key. The last three I'm going to show you are one other type of the hinge theorem and converse. So I'm just going to do 10, 11, and 12, and that is it. So number 10, you're still going to use the hinge theorem or the converse by looking for two sets of equal sides. So go ahead and tick 6 and 6. And then let's double tick 7 and 7. Now, you have to find the included angles. That's because it's SAS inequality. So let's circle the 102. And then this is the included angle here. Okay, how do I know which one's bigger? Well, 102 is across from 12, and 7x plus 4 is across from 8. So that means 102 is going to be greater than 7x plus 4. That has to be because 102 is across from 12 and 7x plus 4 is across from 8. Now, I have to solve this. So it's been a while since you've probably solved inequalities. We're going to subtract 4. So this is going to be 98 is greater than 7x. And then you're going to divide by 7. And I'm going to get 14 is greater than x. And then just to be polite to my teacher, I'm going to use the symmetric property and flip it around and write x is less than 14. So that will be my final answer for what x has to be based on my hinge theorem or converse that I was using. Okay, so let's try number 11. So this is an equilateral triangle. So by that, I also know it's equiangular. So 60, 60, and 60. And now I'm going to look for SAS. Okay, so I have these two sides, and then I'm going to use these two sides, and I'm going to circle the included angles. So the included angles I'm going to be using are this 45 and that 60. Now go across from those angles. Which side do you think is going to be bigger, x plus 5 or 3x minus 7? Well, x plus 5 will be greater than 3x minus 7. And that's because x plus 5 is across from a 60. Now, I'm going to solve this in a way that reminds you of something that you need to do when you solve inequalities. So go ahead and subtract 3x, just so I can show you this example. This is negative 2x plus 5 is greater than negative 7. Subtract 5. Negative 2x is greater than negative 12. Now, one thing you need to remember is if you divide by a negative, you have to reverse the symbol. This is an Algebra 1 topic that when you divide by a negative, you have to reverse the symbol. So my final answer, I'm going to write it up here, is going to be x is less than 6. So anytime you divide by a negative in the last step, it's also if you multiply by a negative, your symbol will reverse and you'll get x is less than 6. All right, one more example, and then we're done for notes forever until 2021. All right, so for this one, we're going to do SAS again. So tick the 8 and the 8, double tick the reflexive, circle the included angles, and then go across from the included angles. Okay, 135 is bigger than 95, so 3x minus 2 will have to be greater than 10. Okay, so I'm going to add 2. 3x is greater than 12. I'm dividing by a positive, so I don't need to flip my sign. I just leave my symbol the same. X is greater than 4. That is the restriction that x has to be based on the hinge theorem or the converse. Okay, so the ones we skipped, I want you to go back and try, and then we're going to check them, or you will check them with the answer key online.